Somewhere right now, 3 billion miles from where you're sitting, it is raining diamonds. Not metaphorically. Not an exaggeration for a pop song. Actual, solid, crystallized carbon falling by the ton through storms of methane toward a core hotter than the surface of the sun. Sounds impossible, right? Except scientists didn't just theorize this, they recreated it in a lab with lasers powerful enough to simulate the crushing heart of a planet. And what they found doesn't just explain strange weather on a world you'll never visit. It might explain why that planet's magnetic field is completely, bizarrely broken. Stick around, because this story involves plastic, X-rays, and a very expensive way to make the smallest diamonds you will never get to keep. Let's start with the planet in question, Neptune, and its slightly smaller twin, Uranus. Together, they're called ice giants. Not because they're covered in ice like a hockey rink, but because underneath their thick atmospheres they hide super-hot, super-pressurized fluids. Back in 1981, a physicist named Marvin Ross published a strange idea about what might be happening deep inside them. He suggested the pressure down there might be strong enough to rip methane molecules apart and squeeze the leftover carbon into diamond. For decades, this stayed exactly what it sounds like. A wild theory nobody could actually test. There was no way to fly a probe down into Neptune's crushing depths and check. The pressures are millions of times greater than on Earth. Any spacecraft would be flattened, boiled, and dissolved long before it got anywhere close to that depth. So if you can't go to the planet, scientists decided to bring the planet to them instead. And what they built to do that would completely change how we think about diamonds forming inside other worlds. In the 2010s, a team led by physicist Dominic Krauss set out to recreate Neptune's interior in a laboratory. Not with a giant ice giant simulator, but with something you'd find in a hardware store, plastic. Specifically, a cheap polymer chemically similar to methane, made of the same mix of carbon and hydrogen. The idea was simple. If methane really breaks apart under pressure, this plastic should do the exact same thing. They took the material to two of the most powerful laser facilities on Earth: the LINAC coherent light source at Stanford and a laser called Sandia's Z machine. These aren't your average laser pointers. For a fraction of a second, they generate more power than the entire United States power grid. They blasted the plastic with a shock wave, instantly recreating conditions found 10,000 kilometers below Neptune's clouds. Roughly 1.5 million times Earth's atmospheric pressure and temperatures over 9,000 degrees Fahrenheit. That's hotter than the surface of most stars you can see at night. And then, for a window lasting billionths of a second, they took a snapshot using X-ray. A snapshot of exactly what was happening to the atoms inside as the shock wave tore through the plastic. Here's where it gets almost unbelievable. In that impossibly short flash of time, something extraordinary showed up in the data. The X-ray pattern revealed hydrogen and carbon atoms splitting apart from each other, and the carbon atoms, now free, were snapping into a tight, orderly lattice. That lattice is the exact atomic structure of a diamond. In other words, the scientists didn't just support Marvin Ross's 40-year-old theory. They watched diamonds form in real time, under conditions matching the inside of an actual planet. Using a piece of plastic, and some of the most expensive light in the world. The diamonds themselves were tiny, nanometers across, smaller than a speck of dust. But the physics scales up perfectly. Inside Neptune and Uranus, this process likely happens constantly. Diamonds forming in the atmosphere, growing as they sink, falling like rain through thousands of kilometers of fluid. Some estimates suggest these ice giants could be raining down thousands of tons of diamonds every single year. Somewhere out there, an ocean of diamonds might be pooling directly on top of Neptune's rocky core. Now here's the twist nobody was expecting. This isn't just a cool fact about outer space bling. It might explain one of the strangest unsolved puzzles in our solar system. Why Uranus and Neptune have completely broken lopsided magnetic fields. As solid diamond chunks sink through the fluid interior, they could drag electric currents along in messy, uneven patterns. Instead of a smooth magnetic dynamo like Earth's, you get something closer to a churning, lopsided mess. A 2024 study suggested this diamond rain could be actively reshaping both ice giants' magnetic fields right now. So, could we ever actually witness diamond rain in person? Almost certainly not. And not just because of the 11-hour one-way trip at light speed to send a message home. Neptune's atmosphere alone would crush and vaporize any spacecraft before it reached those diamond-forming depths. The only spacecraft to ever visit these planets, Voyager 2, only skimmed past from a distance in the 1980s. No mission has been back since. That's why scientists keep turning to laser labs instead of rockets. Every improvement in these experiments pushes closer to the true conditions inside these planets. And this isn't just about Neptune and Uranus. Thousands of known exoplanets are ice giants, just like these two. If diamond rain is common here, it might be an ordinary weather pattern on countless worlds across the galaxy. So let's recap. 3 billion miles away, diamonds are forming out of crushed methane and falling toward a planet's core. Scientists proved it by blasting plastic with some of the most powerful lasers on Earth. And it might be the secret behind one of the strangest magnetic fields in the solar system. If you learned something new today, hit like and subscribe. The universe has plenty more secrets, and we're just getting started. See you on the bright side of Neptune.